Fluorescent lights, including strip lights, are generally not recommended for use in environments that exceed their maximum operating temperature. This is typically around 104 degrees Fahrenheit or 40 degrees Celsius. Exceeding this temperature can lead to premature ballast failure, a shortened lamp life, and potential safety hazards. In a room where the temperature is constantly maintained at 125 degrees Fahrenheit, which is about 52 degrees Celsius, fluorescent strip lights are likely to experience significant issues. Firstly, consider the thermally protected ballast. The thermally protected ballast in fluorescent lights is designed to shut off the light when the temperature exceeds a certain threshold. This prevents overheating and potential fire hazards. In a room with a constant temperature of 125 degrees Fahrenheit, the ballast is likely to repeatedly trip, resulting in frequent flickering or complete failure of the light. Secondly, consider lamp life reduction. High temperatures can accelerate the degradation of fluorescent lamps. This leads to a shorter lifespan and reduced light output. Thirdly, consider safety concerns. Overheating of the ballast or other components can pose electrical hazards, such as an increased risk of ignition or electric shock. Therefore, it is strongly advised against installing fluorescent strip lights in a room with a constant temperature of 125 degrees Fahrenheit. For a room where the temperature is maintained at 125 degrees Fahrenheit, consider alternative lighting options that can withstand high temperatures. One alternative is LED strip lights. LED strip lights generally have a higher operating temperature range than fluorescent lights, making them more suitable for high-temperature environments. Another alternative is incandescent bulbs. Incandescent bulbs can operate at higher temperatures and are less susceptible to overheating than fluorescent lights. However, they are less energy efficient and have a shorter lifespan. Another option could be high-temperature fluorescent fixtures. Some specialized fluorescent fixtures are designed to operate in high-temperature environments, but these may be more expensive and may not be readily available. When selecting lighting for high-temperature environments, it's important to consider factors such as the operating temperature range of the fixture, energy efficiency, lifespan, and safety certifications. Always consult with a qualified electrician or lighting professional to ensure that the chosen lighting solution meets the specific requirements of the application and complies with all applicable safety standards. The use of fluorescent lighting in environments exceeding the rated temperature can have multiple adverse effects. Firstly, the ballast, which regulates the voltage to start and operate the lamp, is sensitive to heat. Overheating can cause the ballast to fail prematurely. The thermal protection mechanism, designed to shut down the ballast at high temperatures, may repeatedly trip, leading to intermittent light operation or complete failure. Secondly, the lifespan of the fluorescent lamp itself is significantly reduced at elevated temperatures. The chemical reactions within the lamp that produce light are accelerated by heat, leading to faster degradation of the phosphor coating and the electrodes. This results in a decrease in light output and a shorter overall lifespan. Thirdly, high temperatures can affect the integrity of the fixture's components. Plastic parts may become brittle and crack, while metal parts may corrode more quickly. This can compromise the safety and reliability of the fixture. Fourthly, the efficiency of fluorescent lamps decreases at higher temperatures. The optimal operating temperature for most fluorescent lamps is around 77 degrees Fahrenheit. At 125 degrees Fahrenheit, the light output and energy efficiency will be significantly reduced. When selecting alternative lighting options for high-temperature environments, consider the following factors. Firstly, the operating temperature range. Ensure that the selected lighting fixture is rated for continuous operation at the expected ambient temperature. Secondly, energy efficiency. Look for options that provide adequate light output while minimizing energy consumption. Thirdly, lifespan. Choose fixtures with a long lifespan to reduce the frequency of replacements. Fourthly, safety certifications. Verify that the fixture is certified by a reputable testing laboratory such as Underwriters Laboratories or Canadian Standards Association to ensure that it meets safety standards. LED lighting is often a good choice for high-temperature environments due to its higher operating temperature range and energy efficiency. However, it's essential to select LED fixtures specifically designed for high-temperature applications. These fixtures typically incorporate heat sinks and other thermal management features to dissipate heat and maintain optimal performance. Incandescent lighting can also be used in high-temperature environments, but it's less energy efficient and has a shorter lifespan than LED lighting. Consider using high-temperature incandescent bulbs designed for use in ovens or other high-heat applications. Specialized high-temperature fluorescent fixtures are available, but they may be more expensive and difficult to find. These fixtures typically use special ballasts and lamps designed to withstand high temperatures. Always consult with a qualified electrician or lighting professional to determine the best lighting solution for a specific high-temperature environment. They can assess the specific requirements of the application and recommend a safe and reliable lighting system. Remember that safety is paramount when dealing with electrical equipment in high-temperature environments. Ensure that all installations comply with applicable electrical codes and safety standards. Regularly inspect lighting fixtures for signs of damage or wear and replace them as needed. Avoid overloading circuits and use properly rated wiring and components. Also consider the effect of humidity. While the initial question mentioned high temperature, humidity can play a role in the longevity of lighting systems as well. Condensation can lead to corrosion and electrical shorts. In environments with both high temperature and high humidity, look for lighting fixtures that are rated for both conditions. These fixtures will typically have sealed enclosures and corrosion-resistant materials to protect the internal components. Furthermore, consider the effect of cleaning agents. In some dough-rising rooms, it may be necessary to use cleaning agents to maintain hygiene. Some cleaning agents can be corrosive or damaging to lighting fixtures. Choose fixtures that are resistant to the cleaning agents used in the environment. Stainless steel or other corrosion-resistant materials are often a good choice. Moreover, consider the impact of vibrations. Some dough-rising rooms may have equipment that generates vibrations. Vibrations can loosen connections and damage lighting fixtures. Choose fixtures that are designed to withstand vibrations, or use vibration damping mounts. And do not overlook the importance of regular maintenance. Regularly inspect lighting fixtures for signs of damage, corrosion, or loose connections. Clean fixtures regularly to remove dust and debris. Replace lamps and ballasts as needed to maintain optimal performance. Furthermore, ensure that the lighting system is properly grounded to prevent electrical shocks. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and interrupting the flow of electricity. It is important to have a qualified electrician inspect the grounding system regularly to ensure that it is functioning properly. Also, consider the use of emergency lighting. In the event of a power outage, emergency lighting can provide illumination to allow people to safely exit the room. Emergency lighting systems typically consist of battery-powered lights that automatically turn on when the power goes out. It is important to test emergency lighting systems regularly to ensure that they are functioning properly. Furthermore, ensure that all lighting fixtures are properly installed and supported. Improperly installed fixtures can fall and cause injury or damage. Use appropriate mounting hardware and follow the manufacturer's instructions for installation. It is also important to protect lighting fixtures from physical damage. In some environments, lighting fixtures may be exposed to impacts from equipment or personnel. Use guards or shields to protect fixtures from damage. Also be aware of local codes and regulations. Electrical codes and regulations vary from location to location. It is important to comply with all applicable codes and regulations when installing and maintaining lighting systems. Consult with a qualified electrician or building inspector to ensure that the installation meets all requirements. Also, when considering LED lighting, be aware of the different types of LED available. There are several types of LED, each with its own characteristics. Some LED are more efficient than others, while some have better color rendering. Choose LED that are appropriate for the specific application. Another important factor to consider is the color temperature of the light. Color temperature is a measure of the warmth or coolness of the light. It is measured in Kelvin. Low color temperatures, e.g. 2700 Kelvin, produce a warm, yellowish light, while higher color temperatures, e.g. 5000 Kelvin, produce a cool, bluish light. Choose a color temperature that is appropriate for the application. For dough-rising rooms, a warm color temperature is often preferred. In addition to color temperature, it is also important to consider the color rendering index, or CRI, of the light. The CRI is a measure of how accurately a light source renders colors. A CRI of 100 indicates that the light source renders colors perfectly, while a CRI of 0 indicates that the light source does not render colors accurately at all. Choose a light source with a high CRI for applications where accurate color rendering is important. For dough-rising rooms, a high CRI is not typically required, but it may be desirable if the room is also used for other purposes, such as quality control. Consider also lighting controls. Lighting controls can be used to adjust the light level in a room. This can save energy and improve the comfort of the occupants. There are several types of lighting controls available, including dimmers, occupancy sensors, and daylight sensors. Dimmers allow you to manually adjust the light level. Occupancy sensors turn the lights on when someone enters a room and turn them off when the room is empty. Daylight sensors adjust the light level based on the amount of natural light available. For dough-rising rooms, dimmers may be useful to adjust the light level based on the needs of the process. Occupancy sensors can also save energy by turning off the lights when the room is not in use. Make sure that any lighting is compliant with National Electric Code. Article 500 of the National Electrical Code, or NEC, covers hazardous locations. If the dough-rising room contains flammable gases, vapors, or dusts, it may be classified as a hazardous location. In hazardous locations, special electrical equipment is required to prevent explosions or fires. Consult with a qualified electrician to determine if the dough-rising room is classified as a hazardous location and to select appropriate lighting equipment. Also, lighting systems should be designed to minimize glare. Glare can cause eye strain and fatigue. There are several ways to minimize glare, including using fixtures with diffusers or reflectors, positioning fixtures to avoid direct view of the light source, and using low glare lamps. Furthermore, consider the uniformity of the lighting. Uniform lighting provides consistent illumination throughout the room. This can improve visibility and reduce eye strain. To achieve uniform lighting, use a sufficient number of fixtures and position them strategically throughout the room. Be aware of energy efficiency standards and rebates. Many states and local governments offer energy efficiency standards and rebates for lighting equipment. These standards and rebates can help you save money on your energy bills and reduce your environmental impact. Contact your local utility company or energy office to learn more about energy efficiency standards and rebates in your area. Also, make sure that any lighting is installed with proper wiring. Proper wiring is essential for the safe and reliable operation of lighting systems. Use properly sized conductors, make secure connections, and protect wiring from damage. Consult with a qualified electrician to ensure that the wiring meets all applicable codes and standards. Finally, consider the life cycle cost of the lighting system. The life cycle cost of a lighting system includes the initial cost of the equipment, the cost of installation, the cost of energy, and the cost of maintenance. When selecting a lighting system, consider the life cycle cost rather than just the initial cost. A more expensive system may have a lower life cycle cost if it is more energy efficient and requires less maintenance.